recording my screen. 1, 2, everything is recorded. Then I'm sharing my screen, my entire screen, and it's going to look like that. So, and meet. All right. Okay, so let's begin. I'm not so sure it will be very long workshop, but it will be pretty concentrated. I would say what I would like to cover today with you, and also with your help, hopefully, you will find some additional stuff. So basically, I wanted to talk about the cameras and very basics of the cameras, how it's built, and all the aspects that kind of camera have, what cameras produces. And of course, we're talking about this not just for fun, we're talking about this that we will understand our material better. So in the end, we're receiving something which looks in a certain way, or we have to achieve something, and I think it's not so bad idea that we will know why things are looking in a certain way, and we will be able to achieve better results if we basically know actually how it was created. All right, so let's start from very basic, how picture is created. Here what you can see, this is example from, I guess, around 16th century. It's called camera obscura, and it was created initially in order to observe sun eclipses and not being blind. So people just made little hole, and then you have basically all the rays coming inside. And here there is little lens, very basic one, a spherical lens. And what's happening is just images going through the convergence point, and that's already first term that you probably want to remember. Okay, it's where all the rays are converging. Okay, there's no magic happening. It's just like, you know, if you in one place, you see from this place everything, meaning all the rays going there. And then with the lens, they are rotated, and on the other side you have the inverse picture of the object. And in the case of first astronomers, it was the sun, which was way darker because hole was very little. So here we're coming already to aperture. So the bigger hole, the more light will come inside. The smaller hole, the less light will come inside. So already we kind of like starting to get very, very basic things. Now let's go to a little bit, let's go like 400 years forward, and let's talk about the cameras that we have right now. This is whatever image I found on internet, but basically it will give us a very good explanation of what's happening or which parts each camera is going to have. Okay, so first of all, we have an object here, fine. Then first thing first, we will have a lens. As you can see, it's concave lens. And this lens will collect the rays that's coming from all over the place, and then it will bend them, as you can see. And here the convergence point, we see, remember that was the previous picture, it's where all the rays are converging. Okay, but let's go backwards. So we will have a lens, we will have an aperture. What is an aperture? We'll talk about this a little bit later, but I already mentioned this. It's some object inside of the camera which will just tell us how much light we want to let into our camera. And then we have a shutter. It's positioned here in this picture, but it can be also somewhere in the middle, and so on. It doesn't matter too much. And then in the end we will have a film, meaning the rays are coming inside, they're flipped, they're converging, and then they coming apart again when they flipped, and then they're recorded on the sensor or the film. So basically every camera will be built like that. Now what I would like to do, I would like just to go kind of like one by one, and kind of like and talk about the how it's going to affect us. So, but before that, okay, so how the lens is built, we already mentioned. We have a front element, and then we'll have series of lenses there. Okay, and we can see here aperture. Let's see what I'm going to talk here about. What we can talk about here, it's about the basic. No, let's keep going. It's just basically that's fine. That's not something that I would like to talk too long. Now let's talk about accessories, because it's kind of like nice to be able to have a vocabulary when you're talking about your picture. For example, most of our and here what we see, it's a matte box. Okay, and something that I would like to talk about, that it's kind of like usual thing that we see on top of our matte box. It's this flag. Okay, that's the matte box, that's the flag, and it's called French flag. Okay, It's called top French flag. So when you next time mentioning that you have some black thing on top of your screen, you say, well, I have a French flag, and not I have some black thingy there. Okay, it just sounds a little bit better, and it's nice that somebody will understand that you actually know what you're talking about. Each mat box can be also can have a side flags or benders. It's depending on which country you're talking, like, or you shooting. Okay, so it's just connected here. You always can open it and close it. So basically, why we have that? We have that in order to block the sun. Okay, block the lights. And it's needed basically on every single film production. Otherwise, you will be not able to shoot, because a lot of the lights, for example, the backlights, and just give me a second, I will turn this off, because that will annoy shit out of me here. How they do that? Stupid. Okay, found it. Okay, sorry guys. So basically that's the part which kind of important, because you just want to know vocabulary. Okay, so additional things that we have with the mat box, it will be these guys, which I will talk in a moment. It's called a filter tray. Okay, I'm pretty sure not too many people know about this kind of like these guys, except of people that actually did shoot stuff with the cinema cameras. And this guy can be rotated, the filter. Okay, and I will arrive to filters in the moment, but basically right now I'm talking just about the main parts that you kind of should know, even as compositor. Okay, so that's the main things. What else that is kind of can be important with the mat boxes? Nothing else. Let's keep going. Okay, so now let's talk about the things that will affect our picture before it's coming to contact with the lens and the filters. And I'll go just one by one. And first of all, the UV filter. I think most of us familiar, whoever was holding camera in his hand, are kind of like familiar with the very first filter that you're going to have on your lens for, yeah. So for example, I have here UV filter. What this filter is doing is basically blocking the UV radiation. So basically as a humans, we a little bit less sensitive to UV light, so we don't see it as terrible as the camera, but cameras usually will catch it way better. So if you especially have tele-lens camera, meaning that you're shooting very far away, it has all the distance to collect too much of the UV light, which is blocking actual visibility. So that's why you will have the UV filter basically on every telephoto camera, like, because you just, you know, it's just a good thing to have. In cinematography, I didn't see it in use, but if you will use, of course, long lens, you will put. And by the way, each mat box will have not one, but few, 2 or even 3 sets of the filters that you will want to put. Okay, and we will get there in a moment. We're coming to the gradient neutral density filter. This is one of the most common used filters on set, from what I kind of remember. So first of all, let's talk about neutral density filters. It's called usually ND, and it looks like I have few. It looks like that. Okay, simple. It's black. It's has no color, and basically what's happening is that. Okay, you put this, you rotate it, nothing is happening. What neutral density filter is does? It's reducing amount of light which is coming inside of your camera. Why we would like to use that? I will talk about this a bit later, but we have kind of like many types of them. Each one will, for example, this is 0.6. So this one will reduce 0.6 of stop. Or you can reduce 1 stop, you can reduce even 2 stops, and so on and so on and so on. But here we're arriving the first one, which is gradient ND, and that one is used tremendous amount of time on set. I guess you're guessing when we're shooting in front of the bright sky, so you want to darken sky, so sky will be not overexposed, and you put this gradient, and if you position this properly, it does kind of like just preventing sky from being blown. Okay, so that's the gradient neutral density. Then we have warming and cooling filters. Okay, so these guys basically correcting your white balance, and this is way more important. Maybe I'm not kind of correct, but I think it's way more important with the film cameras, because film material has fixed every year when I'm talking about the film cameras, I kind of understand more and more that I'm talking about the past, because less and less movies shot on film, but still I think it's good to know. So the film cameras, actually the film material has fixed Kelvin temperature. Meaning, I have here one example of the Kodak negative film, and it's you probably cannot read it, but it's written on the box 3200. Meaning this material is white balance is set to 3200 Kelvin, which is the temperature of simple light at home. We covered this already in some workshops. Actually, it's not temperature of normal light at home. It's colder because our usual bulbs, the old ones, it's like 2800. But anyway, if you're shooting at home or inside in the interior, you will shoot with the 3200 most likely, if you're not using the daylight lights. And here we're coming to warming and cooling filters. For example, you're shooting outside, and then outside it's 5600. Your material will be for most likely with the base temperature 5600, but it's very cloudy, so it's, like in video it's very easy, you already will see, but with film you don't see it before you actually going to lab, and already a little bit too late. So if temperature outside is way colder, you want to put warming filter on your camera to level your white balance. Okay, warming and cooling filters. Usually I probably have it somewhere here, but I don't want to dig. It usually will be like a cotton one, and second one will be kind of cyanish bluish. Okay, similar that you have filters in the Photoshop. Polarizing filter. So this one is important when you're shooting something. Like, first of all, we all most likely know polarizing filters because 3D guys using this a lot to extract proper textures. So, but it's used also on set huge amount of times, every time when you want to kill reflections, and it does work very magically. I didn't find polarizing filter, but I have somewhere one. Basically, it's killing certain with a certain angle, it kills the reflection. So you put the filter, and that's why in matte box these guys are able to rotate. Not with this one. This one is cheap. Or no, it does, yeah. Okay, so you will catch specific reflection to kill it. Okay, so this one is extremely useful. For example, it's most likely going to be used every time when you're shooting the car sequence. Okay, camera outside, you're shooting through the windshield, you see nothing because you see reflection of the sky. You put the polarizer, and you see guys inside of it. It's bloody magic. It's kind of like, well, how does it work? But it's cool. Okay, then softening filters. It's something that kind of we're not recommending to use basically already for some 20 years. It's filters basically that softening the material. This cheesy video or films with these stars, when everything is just starry look, or everything is just soft slightly. So basically we have filters which called like black promised, white promised, and this is special effect filters that if you want to create a sequence which has this very soft and nice, the advertisement look, okay, in the morning, the sunshine, the sun flare, and everything is soft and sweet and with the flares, you will use probably the softening filter. We're doing this in post, but this effect is also, it's quite nice. The funny gag that I did, kind of like a joke that I learned as a student, that you can achieve the same result if you put the sock or the transparent sock on the lens. It's also making this kind of like, it's basically dispersing the light, and it gives you also this nice soft effect. You can try it with your iPhone, it also will work maybe. All right, so this is filters. That's kind of like, I think it's good for general knowledge. Now, let's go to next one. Boom. By the way, what we can do, we actually can, each time when I will move, if you have something to add, please be kind of free to say like, well, I used this filter or maybe that, or something I'm missing, I'm saying something wrong, or I'm not kind of like exact with my claim. Please tell me, because there's many things that I don't know, and I think it will be nice that people will learn more stuff than I can kind of like just say. Okay, so let's move to the next one. So next one, it's a lens aperture. Okay, in the very first example, when I was showing the camera obscura, I told you the hole is defined. The size of the hole is kind of like defining how much light is coming inside of the lens. And that's the guy that we all familiar with. That's the kind of like aperture ring. It not has to be. So this one, for example, I also brought very funny lens. It's called Lens Baby, like just like 15 minutes ago. It has fixed aperture, and you can take just the ring out, which I will do right now. That was the ring of aperture, and you can exchange it. So this one is like 2.8, and then you throw it there. And then you have your aperture, and then you can change the rings and stuff, but it's easy when it's already inside of your lens. Now let's talk about how the aperture will affect the light. So first of all, we measure aperture with f-stops or t-stops. Okay, so f-stop and t-stop, it's almost the same, just t-stop is a little bit less than f-stop, because t-stop is telling how much light actually is coming to the sensor. F-stop is telling how much light is going through the aperture. Okay, and each time when you're increasing the stop, and their numbers are super weird, which will, for example, each one is jump of one stop. Okay, 1.4, 2, 2.8, 4, 5.6, and 8. It's like each time you reducing, in this case, amount of light by 2. Okay, it's half. Each time is half of the light is coming inside. It is important for later. And what are additional consequences of opening and closing the aperture? So first of all, each stop reduces the amount of light by half. Cool. Important when you're shooting, you don't want to shoot with very open aperture or with very close aperture. Okay. So each lens has like this so-called sweet spot when the aperture size is just good enough to not produce any kind of artifact. So when your aperture is too closed, you're starting to get some image degradation, and I think it's happening just because it's similar, like I think it's connected to the lengths of the certain colors, the wavelengths. So they're starting, the hole starting to be too small, so some of the rays are starting to break, and that's when you're starting to get some issues. Correct me if I'm wrong, because I'm pretty sure that somebody will know it better than me. And when you're opening the aperture, there's too much light. It's coming inside, not because it's overexposed, but it's starting to be a little bit more milky. Of course, defocus, but we'll talk about later, exactly now. And closer aperture, creating picture which is more in focus, while the aperture, when aperture is closed, our depth of field, while aperture is open, depth of field is more shallow. Okay. So another very important part, if you want very defocused image, and one of the things that you would like to do probably is to open your aperture. And open apertures will be, for example, 1.4, and very close will be 8, 16, or 22 when we're going like quite crazy. For example, when you're shooting outside. You remember neutral density filter? Remember that, okay? Because we will use neutral density filter to reduce amount of light, similar to what aperture is doing, but without the paying for the depth of field change. Okay, so now we're having already two elements that cameraman can play with to affect the quality of the picture and to have different trade-off. Okay, no change with the depth of field if you're using the neutral density filter. Okay, so additional stuff about aperture. Let's keep going. All right. So focal length. Okay, focal length. So first of all, let's talk about what focal length is. Okay, so where is this coming from? So basically, if this is the lens and this is the first lens when we're entering, there will be the big one. And basically, the distance between the area with the middle of the lens and to convergence point, it's supposed to be the focal length. Okay, so it's how fast the rays are converging. We were talking about the convergence, right, in very, very beginning. So the longer lens will have longer distance, the wider lens will be shorter. So when we're talking about, for example, 18mm lens, usually it will be quite little one, okay? I mean, the things very much changed and changing and stuff, but that's the general explanation of the term. And 300mm lens, we'll have the focal length which is way, way longer, theoretically. Okay, there is lenses which are kind of solving this problem internally, so the rays are going back and forth, and that's why lens is actually shorter. But this is just explanation about the term. Okay, the another one that you can use is field of view. Instead of talking about the lengths, focal lengths, about this distance, you're talking about the angle. And that's usually what we're doing in our 3D world, okay? and that's kind of like that's how we see. Okay, the field of view will be, for example, 90 degrees or 180 degrees. That's something that you read usually in your cameras, and I think it's more kind of like up-to-date way to judge the lenses, but still we all will use something like that. Okay, so now let's go on the kind of points that probably we want to touch. So lens focal length is related to the sensor size. Okay, what I'm talking about, and that's the image down there. So, and now we coming to the next player is the sensor, and we'll arrive to this later. But generally, if you have, usually, if you have, for example, a lens which is 35 millimeter, it's written on the lens, 35 millimeter, it's fixed lens. And with the field of view on this lens, with the sensor of full frame 35 mil, will be different than field of view of this lens with the 16 millimeter camera. Okay, so you will have always to multiply, and here there's a kind of explanation. So this is 50 millimeter, it's the same focal length, but basically the result is different on two different sensor sizes. Okay, you easily can go to internet and find the calculator. So how do I transform? For example, I have a 200 millimeter lens, but my sensor is for example, let's keep it simple, like 16 millimeter, okay, and not 35. And then you will probably have to multiply it by 1.5, and then you will get the actual focal length that you have. Okay, so that's important. So there's another player that we have, it's the sensor size. Longer lenses have more shallow depth of field. Okay, so that's important. Okay, the wider the lens, the more stuff you can put inside of the focus. The longer the lens, the more shallow depth of field is going to be. Okay, so that's quite important consideration when you creating the final picture. Okay, I always asking myself, what was the lens? Okay, so for example, you have picture of me right now, the lens is kind of like pretty wideish, and also sensor is very small. We will get there. Okay, so if I will have to recreate the same picture, probably I will create my background quite focused. But then imagine just in your head any footage of somebody is riding on the horse and camera is following this guy. All the background will be like completely out of focus, because most likely somebody was using the long lens, focused on it. Every National Geographic photography, okay, just remember, everything on the background will be completely defocused, the lines in focus, the everything else is defocused. Okay, important for kind of to convey certain idea when you're comping which lens was used. Longer lens collecting more atmospheric artifacts. I mentioned already the UV filter that you probably would like to put there. Okay, just because it's going through way more distance, okay, than wide lens. It's collecting like in this area, except of collect just like the whole picture. Longer lens, more prone to camera shakes. Okay, very simple kind of like the idea. If you want to do handheld video, you probably want to use the wide lens, because if you're going to try to run with the 300 millimeter camera, you're doomed. Okay, it's just impossible, because again, it's zoomed into very little area, and every little rotation is going to completely destroy image. So that's why when people shooting something with a tele lens, you will use you will just put camera on tripod, and then you will do your job. Okay. Again, why I'm talking about this, it's important when you're trying to mimic something and you know that it was shot with the tele lens. You need to consider, okay, can it be handheld? Will it look natural? Because it can't. It just can't look natural. If you use 300 millimeter lens in your shot and you say, well, that was handheld, he was running. No, it can't. If you're running with this lens, it's going like that, the picture. Okay. Wider lens has more lens distortion. Okay, that's quite self-explanatory, but it's actually not. Okay, let's talk about that. Why? Okay, so if you have long lens, meaning that the rays which are arriving, it takes them longer to converge. So you remember what was it? The focal length, kind of focal length, exactly, longer to converge, meaning the angle that they creating with the lens is smaller, meaning there is less artifacts. So like it's similar, you're looking on the surface of the water from the top, almost no refraction. From the side, there is refraction, starting to get some artifacts. Similar happening with the lenses, okay? So on the edges of the lens, when the refraction is the strongest, okay, here, okay, on these edges, you will start to get chromatic aberration. Wider lens, the more of the lens is used, the more lens is bent, okay? Because with wide lens, you really want to collect as much material as possible, and you have to converge it very fast, okay? So wider lenses, more like technically just going to have more chromatic aberration, more artifacts on the edges, okay? Longer lens from other side, again, there is less refraction effect happening, meaning the picture will be more less kind of like less fucked up, let's put it like that. Wider lens, more chromatic aberration, and lens distortion. I mixed chromatic aberration and lens distortion, but it's kind of like connected, okay? Now the are kind of like the most kind of advanced, the last lenses, and I'm talking about the last 50 years already, like it's basically advancing all the time. They can fix the lens distortion inside of the lens itself. So there's very smart lenses with doing very cool job, but basically it's going to be all the time. Wide lens, more lens distortion. So if you have to apply lens distortion, don't just throw stuff on it, okay? If it's long lens, there's no way in the world that long lens will have a strong lens distortion. If you have wide lens, go crazy. If you want to say, well, this is the fish eye, and it's generally the fish eye look, that's so wide that you cannot deal with lens distortion. So it will be kind of like very, very, very distorted in your comp. Let's keep going. Okay, focus. A few things that I would like to mention about focus, something that I didn't mention yet, and some stuff I already mentioned. One of, there's two actually, the most important, but I wrote more. So first of all, the ratio in the defocus in depth of field is not 1:1, and it's I find it's very important. What I'm talking about, you can see here, that's the picture of the area in focus, and on top and on the lower one, you can see that the distance from the focus area to the front and from the back is not the same. Usually what I was taught, it's like it's 1 to 2, but it is changing with the distance, okay? So basically what you want to always have a look that you have here less and here at least twice more stuff in focus when you're creating your defocus, okay? Another important stuff, more open aperture, more shallow depths of field, okay? That's something that I mentioned already. 2.8, you will have shallow depths of field. And closer to camera, also your depth of field will be more shallow. But I'm talking about the, actually, it's more far away from the camera. I kind of like, I lied. When we're very, very close to camera, then we're starting to be kind of like really, really shallow. If you put micro photography, for example, or when we're getting more far away. Okay, so that's kind of like two things that you need to consider, but all the stuff which are, yeah, let's talk about the additional stuff about the focus actually. So I didn't write it, but I was thinking about this right now when I was thinking about this. So everything which is on big scale, no depth of field whatsoever. Okay, that's important because we're working on kind of big explosions in the space. And in space, usually when you're shooting the spaceship or planet or whatever, you cannot put focus. Even if you want, and clients sometimes will ask you to do that, but basically it just cannot happen. Okay, in space, no focus. Everything is very far away. Everything is very much in the focus. Okay, just give me a second. I think, guys, I think I'm correct actually. The closer to the camera, the more shallow depths of field. The more far away of the camera, the depth of field area actually is going to grow. I'm not mistaken. Yeah, that's right. Yeah, all good. I'm bullshitting you? No. Important part, depth of field is not thrown in the linear, throwing down, not in linear way. And this is the second important thing that I wanted to mention with depth of field. Something that I see quite frequently in the comps, and people kind of saying, well, I will design some depth of field and it will go it will be, for example, I have a front actor, behind him a wall, like 15 meters away from here, a wall, and this wall will be defocused. But then there is 100 meters away from him a tree, and this tree is going to be way more defocused because we're accumulating defocus, and it's not correct. Your depth of field will drop very fast, and then it will stop dropping after a certain time. It's logarithmic, meaning the wall, which is 15 meters away, and the tree, which is 1 kilometer away, will have similar depths of field. And that's something that when people are faking depths of field in comp, sometimes not getting that the drop supposed to be not linear but logarithmic, meaning they will make again the same mistake. 15 meters away, depth of field like this amount, and 100 meters it's 3 times bigger. And then like, no, it can't be like it. Okay, so let's go to the next one. Questions? Something, comments about focus? All right. No. Okay, so anamorphic against spherical. So I just collected whatever I was thinking, and like I hope that will be somehow correct. So spherical lenses, they are good. We like them, and they're easy to work with. It's just what you film is what you get. Okay, spherical, normal thing, converges, inverted, and we did film it, and our squares are 1-to-1, so we're getting basically square pixels. Okay, that's easy, and everything is amazing. Now we like to use anamorphic lenses, or directors do like to use it from quite some many reasons. And here we have kind of like a picture which looks like that. You see this one, it's stretched. Okay, so I would recommend you, if you never was thinking about anamorphic, there are YouTube videos explaining about the history of anamorphic lenses, of anamorphic material, and it's extremely fascinating, and it's really interesting why it was created, and it's quite cool history. Okay, but anyway, as a final result, we're getting picture which is stretched on the film. 50 years ago, we didn't have digital cameras. We had just a film, and it was just shot anamorphic, and then it was projected back anamorphic. Okay, inside of cinema theaters. Okay, cinema theater lenses had like projectors had anamorphic lenses as well, in order to accommodate this material. Okay. As a byproduct of invention of anamorphic, or the goal, there were a few goals, but basically we have way more resolution, okay, on the picture, because we have way more pixels. And let's see what else. Okay, so flares looks cool. Okay, we love it, and it's on the right side. You can see the anamorphic flares. You kind of like quite frequently we have like a compositor creating a cool flare, and VFX supervisor telling him, dude, this movie is shot with spherical lenses. You cannot get flare like that. And we're trying to be photorealistic here. You know, we're really down to earth. And after 2 weeks, director is like, I want this line and cool stuff. And then we put anamorphic lenses everywhere, flares everywhere, and it's all cool. But basically, that's how they will look like. So they will have these streaks. They will have quite some artifacts. Bokeh will be weird, but we can see here, for example, on top, usually it will be a stretched circular, but kind of like stretched vertically bokeh. I didn't see yet stretched horizontally, but basically that will be the look. And important that anamorphic not have to be 2-to-1. Okay, it's kind of usual thing that will be 2-to-1, but it also can be anamorphic 1.7 or something like that. Okay, so it's kind of like just good to know. Frequently have lens breathing. Okay, so that's something that we also encounter as a problem, or as additional kind of like a good thing. So when anamorphic lenses, you pulling the focus, it's also happening with the spherical lenses, but anamorphic, it's just quite crazy. Your lens distortion is changing when you changing the focus. That's something that I did not mention on my previous slide. I forgot. When you're changing the focus, okay, here everything is happening internally, so my lens is even not going out. But when you're changing the focus, your lens distortion is affected. Okay, so you have to consider this as well. So if you're very, very wide and then you're zooming in and you're faking basically something, you maybe want to adjust lens distortion as well. I never did it, but theoretically, technically, it's what's happening. An additional thing is that when you're changing the focus, the zoom level is changing, especially with anamorphic lenses. Okay, it's slightly zooming in, slightly zooming out. It's called lens breathing. Okay, and the new lenses almost don't have it. It's almost eliminated. But we do shoot quite a lot, or guys do shoot quite a lot movies still with the old lenses, because they are cool. and they're giving this nice softening effect and these cool artifacts and stuff. And so that's something that we should expect. Okay, there's a Itor, I think, created nice gizmo that can simulate that in one go without going through kind of few steps. It did look very cool, and just remember that. Frequently old lenses used, that mentioned. 3D tracking is a pain. Okay, since the material actually is distorted, basically it's impossible to track it, so you have to give to your 3D application the pixel aspect ratio, and then you will be fine. Okay, similar to Nuke, you have to define the pixel aspect ratio, otherwise it will be completely broken. I did one example, kind of like, I'm not going too much today inside of Nuke, but you can see my screen. Sorry, just a second. Pressure, just give me a moment. Yep, getting there. Okay, cancel. So I did one example of a problem that you get with anamorphic stuff inside of your comp. So for example, this is the anamorphic footage, and if you kind of like did not learn and did not do your housework, kind of like homework, you will not recognize that it's anamorphic. But if you press Ctrl-Shift-P, that's the real representation of the footage. Okay, so that's how it looks like, and this is how Nuke is representing this for you. All right, so if I will zoom in and I will try to have a look on the pixel, you can see that our pixels are squeezed. Okay, this ratio 1:2, and now I'll show you the problem that we frequently have, and kind of like we need to be able to deal with that. So we created a rotor on the side, as I kind of asking usually people to do, and it's overt and everything is great. But then if you will try to move this rotor left or right, or rotate it most, kind of like more, I can say, like I will do it like now, you can see that it just doesn't do what you're expecting it to do, right? It's kind of behaving weird, and like why? Because it's anamorphic. It does behave completely correct here, okay, as you expected. But when you're merging this with anamorphic footage, is kind of like saying, well, nope, not going to work. And there's few ways to fix it. There are 3 of them that kind of like we put together. So first of all, you saying this guy is anamorphic footage. So you're giving it the same resolution with the pixel aspect ratio 2. It's just reformat, nothing else. Okay, and now when you will rotate this guy, you will have a result that you expected. Okay, it's happened me on the last project. I was tracking some guy, and I spent much time to track his arms, and then I started to rotate it, and everything went banana, and I was like, oh shit, I forgot. Anyway, not end of the world. Just put reformat. It's that's it. Otherwise, you can use a trickster just to set pixel aspect ratio with the node, with the gizmo aspect to 2. The bad thing here, you're losing your bounding box, but it does the job. And another thing is that you can do is just can pipe your rotor to actual footage, and then it will do the job as well. I mean, you need to set it to replace basically the rotor, but from now on it will do proper sync. Again, you will lose bounding box here, so probably the winner will be the reformat, that you will just change aspect ratio of the stream, and you will keep going. Okay, what else I have with anamorphic examples? Nothing fancy. Okay, good. Let's go back to presentation and F11. How was it? Presenter view. And back here. So Nuke viewer, it's really technically you need to know Ctrl-Shift-P to see the final result. There's the interesting thing is that when you trying to zoom in and working like on the edges, it frequently will be jagged edges. Your masks will have jagged edges because basically you're making your mask and then it's stretched. Okay, it's actually stretched horizontally, and it's quite hard to get rid of this artifact. Okay, so like usually we're just blurring this slightly and hope that it will be fine. But if you have like good tip how to get rid of these artifacts, that's like I'm really open for suggestions. More space needed to save. Okay, back out of Nuke, just generally when you're shooting anamorphic, you need more space, okay? Because, for example, if you're shooting picture which looks like that, it will have specific resolution. But if this is anamorphic, it's actually twice bigger on your hard drive. It's just later squeezed in comp, okay? So every time when you're bidding or whether you're thinking about anamorphic project, you need to consider that actually it's going to be way heavier. On that way, quite heavier, just we deal with it with a sheer amount of material. Can use full sensor of camera. This is the cool thing. For example, if sensor of camera is this, it's 4x3. It's a sensor of Alexa, for example, and you shooting anamorphic, you're actually using all the pixels, meaning the quality of the picture is better, and we'll get to this in a moment. Set aspect ratio in blurs and so on. Okay, important thing to remember, when you're working with anamorphic material, all your nodes don't know that you're anamorphic. For example, if you're using the noise generator, the aspect ratio will be 1:1 there. So if you want your noise to look properly, you need to set scale x1, y2, or the opposite, okay? So noise will be proper size. All your blurs will blur horizontally instead of blurring properly as would you expect, okay? You have to remember quite many tools, defocus, you have to set aspect ratio, and quite some of them, okay? Keep it in your head. All right, shutter speed. So what is the shutter? So shutter is the guy which is telling how much light is going to enter the camera, okay? So how does it work? In the video cameras, it's just basically turning on and off the sensor, something like that. I don't think there will be manual kind of like a thing which is closing this. And of course in film cameras, it's something which is generally manually will close it. So I have a 16mm camera from Second World War here, and I'll just show you like viewfinder going out. And if you will have a look here, I'll just show you a few sides, okay? So here on the back side, on the side, can you see it? I will stop presenting, so I will be like full screen. Am I full screen? Hopefully. Okay, so here you will have the viewfinder area, and here inside it's actually area that is exposed, film which is exposed. I hope it's somehow visible for you. And if you will have a look now,
just as a thing, there is, when you hover over Alexey's image, there is a pin button, and if you press that, he gets maximized. So, you know.
Okay, so now I hope it will be somehow visible. I see myself very little because I'm not pinning I can pin myself. Okay, good. So here, when you're looking inside, and I will rotate basically the mirror, if I will be in focus, and just give me a second. You can see this one, and if you see something, I'm closing this. That's the viewfinder, meaning the picture is going now to viewfinder, and then I keep rotating the ring, and now it will be different thing. It's closed, and if I'll try to go inside, now you see my finger, and now picture is going to the on the film and falling on the film and not on the viewfinder. Viewfinder is closed. Okay, now the diagram of that you can see here on the screen, which I will share in a moment, and I will not forget to share my screen, my entire screen. Check. And kind of like I think it's nice to understand how this thing is working really on technical level. So a usual shutter will be 180 degrees. It's a half, and that's what I'm showing you here on the left side, meaning the half time it will be closed, half time it will be open. Consequences, okay? The slower shutter, the more lights it comes to the center, meaning if it's 180 degrees, the more light will come to the sensor. Now, if we're closing this to 90 degrees, because it's adjustable, okay, meaning the less light comes to the sensor, and so on and so on. More motion blur with the slower shutter, meaning the longer we're exposing, the more material moving, the more material we're catching in time, meaning the motion blur is higher. Standard for cinema, 180 degrees, 0.5 in Nuke. On any other application, I guess. Slow motion footage has higher shutter speed. Okay, explanation. If we're shooting something with a higher frame rate, we have no possibility to have slow shutter speed anymore because frame rate is just higher. Okay, so less light is coming inside, And frequently we will get material which is shot with a slow motion, which will be underexposed, because on set they were kind of like, they didn't think about that if they're increasing the frame rate, the shutter speed will increase as well, meaning less light is coming, and then you get material which is quite dark. Okay. Also, when we retiming or use retime material, we have to consider the shutter speed that supposed to be in the final picture. For example, somebody did shoot something with a slow motion. Okay, there's a zero with slow motion, there's going to be not much of the motion blur, but then we respeed it 400%, so guys do look cool, and we want it to look natural, but they will be kind of staccato. They will move very fast but without motion blur. That's why you always need to remember, what is the actually we want to achieve? Do we want to say that it was speed up, or we want to say no, it's just natural, we're faking, but it's natural? So you have to add additional motion blur according to the desired shutter speed, or desired frame rate, for like 24 frames per second, which means shutter speeds it's 150s, okay, because it's half with 180 degrees, okay. Shutter can introduce flicker with electronics and with the slow motion shots, meaning when we're shooting inside kind of like Europe, for example, our electronics were working on 50 hertz, and if we're not synchronizing our cameras with the electronics that we're shooting, we're going to have an artifact, kind of moving stuff, black and darker. The footage is starting to get darker and brighter. For example, when you're watching the football game and then there is like very cool slow motion, everything is flickering, right? Because our shutter speed is not correct relatively to the lights that they're lighting the stadium. Okay. Let's keep going with the shutter. There is a very cool picture that my grandmother sent me, and I was like, hey, something is very wrong there. And if you see this properly, there is this technisat is very, very defocused, but this picture here is just super sharp, and I was like, what, that's fake. No, it's not. It's because this display has very fast refresh rate, and it just appeared for a very little second before her shaky hands made camera move, and then it disappeared. And that's why it's very, very sharp, and it's almost not natural. Not almost, it's very not natural. Similar effect you will see in the motion blurred footage when like I had some shot with the person inside of the car shooting the board in front of the person, and there was radio as well, and everything was crazy motion blurred, and radio kind of like radio display was on every frame extremely in focus. Completely weird, completely natural effect. Okay, now let's keep going. Main players about pictures, ISO and white balance. Okay, so what is ISO? It's very intuitive. It's International Standard Organization. Kind of like no connection, but that's the translation I found, and that's kind of like, but let's talk about this. ISO, basically it's sensitivity, or how DOPs will call it, the speed of the footage. And it was designed also, here you see a box which kind of like with the codec Vision 3 film material, and we see this number 500. Sensitivity of this film is not changing, it's 500. This is his native sensitivity. That's something that you will be not able to change. Okay, it will stay forever. Okay, so it was very important for cinematographers to choose proper stock. When you're shooting inside, probably will go for material which is white balance tungsten and sensitivity as high as possible. 500 was standard. If you have 800, you're really, really lucky, but basically the usual, it will be 500, and that will be 500 ISO. Now in our cameras we actually can tweak the ISO, and let's see what else we have. So higher ISO, it's faster the film material, it's more sensitive to light, more light sensitive sensor, film is higher ISO, more grain. So this is the trade-off with a higher ISO. More light you can record, more grain, more dirt you're getting on, not dirt, more grain you're getting on your final material. Now the cameras of our days, they are insane. You can shoot natively with 800 ISO, which was like 20 years ago, 10 years ago, completely like, are you crazy? 800 ISO you don't want, you want 50. Okay, which was like the good film material, like 50, 60. All right, so now you can adjust your ISO inside of video camera, but you, yes, introducing more and more and more noise. Every sensor has some native ISO value. So my Canon here, so this guy, it has like 200 if I'm not mistaken. Red cameras and new cameras, they have like 800. That's the beginning. Okay, and then you can go higher. Like, okay. Some ideas about white balance. I will skip it because we don't have much time and it's not extremely important. Let's go to the next one. Okay, so now we collected quite some information, quite some players, and that's the kind of like the triangle. What was it? Brightness triangle or something. So first of all, the aperture. You know, the more open the aperture, the brighter the footage. The higher the ISO, the brighter the footage, but you're getting more noise. Okay, with the shutter speed, the slower the shutter speed, the more motion blur you're getting. Okay, and additionally, I wrote here the filters, the ND filters, and that's how cinematographers could decide, could play. This is all the players, or most of them, that they can play with to design the picture that they want to produce without sacrificing with sacrificing certain other element. Okay, so this is kind of like, this is really ABC of any cinematographer to understand how to play with this stuff. Let's keep going. Oh, that's the previous. Next one, and really important. So sensor, fine. Okay, so the sensor size matters a lot, okay, and the sensor quality matters a lot. So we had at the beginning where the film, okay, our very usual film is a 35 millimeter, or if we have bigger film, it's 65 millimeter. Alexa 65 also will have bigger sensor size. Have fun, have a look on this sensor sizes comparison. So 1 point, like 2 point, kind of like 2/3, I think it's called. That's kind of pretty standard for the like with the cameras, which are basically just with not professional cameras. 1.3, it's even more kind of like a common thing. But now in professional world, we're going to bigger and bigger sensor sizes. Okay, it's not always the best or better, but usually it is, and why it is. Okay, so first of all, we will get more resolution in the big sensor. More resolution, more pixels, more information you can store. Additionally, very important, when you have bigger resolution, it's not always the best, because the small, if you have bigger resolution but small sensor size, you will have a lot of color bleeding. You will have Moir patterns. You will have additional artifacts. So you want to go bigger sensor, bigger pixels as well on the sensor. Here you can see the sensor, the kind of like basically the classical sensor. You have red, green, blue. It's collected. There's a lot of information about sensors. They're slightly different one from the other, but it's important to understand why people are actually going for bigger sensors. It's not just the resolution, it's also bigger pixel size. Better light sensitivity. It's not kind of like 100% correct, but generally you have more surface to grab the light, okay, and it's already kind of makes it easier to catch the light, but that's not always the truth. And important, bigger sensor, depth of field is more shallow. On the right side you have here, this is medium size format, like this, you know, weird cameras, the Hasselblad, and it gives just awesome pictures, like pictures taken 100 years ago with these big cameras, with the kind of like with the metal film. It's not film, but it was metal plates. They have crazy depths of field because actually they took picture on the negative this size, okay, and the resolution is bloody amazing because it's huge. So it has this very nice taste to it. Dynamic range. So better sensors will have better dynamic range, and I didn't expect that, but I collected yesterday information about dynamic ranges. So 20 years ago, all the customer cameras that we have, they're like crazily like 4 stops dynamic range, okay? 35 millimeter 14 stops, and that's kind of the golden standard. iPhone 12 Pro and Alexa do have 14 stops dynamic range as well, at least on the paper, all right? But this is quite funny how far we've got now with the dynamic range, because that was the one of the most important parts. When you're shooting on video, everything is blown up, okay? We're getting there closer and closer. Rolling shutter versus global shutter, okay? So this is so global shutter on the film videos, you will have basically global shutter. Your picture is a very fast closed, very fast exposed, and so on. So it's called global shutter. All the video cameras, and I'm including Alexa there as well, like they will have rolling shutter, meaning the information is not read like that, boom. No, it's read line by line, okay, from top to bottom, if I'm not mistaken. And that's why when you have a very fast move, you will have the rolling shutter even here, okay, even on this iPhone. The smaller a sensor, you kind of getting less a smaller resolution, not always, but basically the rolling shutter will be slightly reduced. The bigger sensor, you need to work hard to kind of to kill the rolling shutter, and then doing great job, okay. But still a lot of material which is arriving to us will have the rolling shutter, and has to be treated separately. Kind of like, you need to understand that with the rolling shutter you cannot track material just by tracking, because picture is destroyed, okay. Additional thing that we're getting from the sensor is Moire pattern. It's this, and here I'm coming to resolution. The more resolution, the better color separation is going to get. If certain very little pattern doesn't know where to hit the sensor, and your resolution is not high enough, it will hit left or hit right, but it will move, okay. And that's what you getting. It's very hard to deal with Moire pattern. I mean, you basically, from what I see, you can't. Basically, if you have it, like, you can blur it a little bit, like some stupid stuff, but it's already baked inside. The material is broken, okay. So the better cameras, the better they're dealing. Usually we will ask people when we're shooting, don't wear shorts like that. Don't wear stuff with a pattern which was very small and repetitive, okay. I'm getting closer and let's to the end. So let's just talk about the order of operations, which is extremely important, okay, because that's what we're doing in comp frequently. So first of all, light is coming and touching the lens. First it will touch the filter, okay, but we don't care about that. It's usually kind of like not important. Then we're going inside of the lens, and few things happening inside of the lens. We're distorting the material, so lens distortion. We're applying the lens distortion. Then we're applying chromatic aberration. We're applying the flares. We're trying to prevent flares with the flags, but there will be flares all the time, or we want flares, but it's happening inside of the lens. Then the light is hitting the sensor, okay, and we're starting to record material. Immediately we're starting to read it, and we're introducing the rolling shutter. We're introducing the motion blur, meaning the defocused material will be motion blurred, and not the opposite, because first we entered the lens, and then we started to record stuff which is already defocused, and then motion blur is applied on top, okay. And then sensor is not perfect sensor. For example, we have very strong green and very strong red standing next to each other. Sensor starting to get a little bit nervous and crazy, and red pixels or green pixels going on top of the red with the certain channels, because in certain areas he was not able to grab properly the material, put it in proper place, and it's called debayering, okay. So this is something that's happening inside of the camera or outside of the camera, because material that sensor will produce, it will be raw material, but we're not working with the raw, we're working with the XR, for example. And raw will have not debayered material how it was recorded. We have one pixel with values red, green, blue, but on the sensor there is no one pixels with values red, green, blue. There is a three pixels next to each other, red, green, blue. How they are connected together, that's called the debayering. So in the cheap cameras, or in every cameras, you can have it inside of the camera and output Apple Pro or some additional things, or you can record the raw, and then you have to go through the process of converting your material, which can fuck up the material or can make it nicer and stuff. So frequently we're getting material, we're like, guys, that's just not right. Okay, and then we have some compression which is happening. For example, somebody will save material with compression 411, and then we're like, guys, we can't work with that. But that's kind of more of a joke. And look at that, I'm done exactly in 1 hour, and you have zero time to ask me questions, but I'm ready to stay. If you have additional questions, additional stuff that you would like to mention, to throw something, well, look, something important that's happened to me, now it's your time.
Yeah, motion blur and defocus are switched in our pipeline.
Can be, and I think even I even did it. No, motion blur and no defocus and the lens distortion was switched. I think, if I'm not mistaken.
No, you're saying in the here that the defocus is happening before the motion blur.
Defocus is happening before the motion blur. Yeah, yes, correct.
And what we're doing right now is motion blur before
Yeah. Okay, so that's something that I also somebody did mention to me some time ago, and I kind of was considering some stuff, and basically I decided that it will be better to go this way, just technically, because I didn't want to defocus all the layers. For example, the motion blur, motion vector layers to I didn't want to distort them. I think it was distortion actually, not defocus. And basically we decided that we will stay this way because it introduces less artifacts basically in our workflow, and it didn't change the picture whatsoever. Nobody never complained, but theoretically that's how it works. I think it's very important, for example, when you have rolling shutter, or when we kind of getting rolling shutter, when like, well, just second, because the rolling shutter is after distortion, before. When you get material rendered without distortion, you need to kind of like you really have to know the order, otherwise it will not sit. But with motion blur, it was kind of like, well, that's we can tolerate it. All right, so everybody have to leave, and I also actually have to leave. So I hope that like we did learn something today, and I'm really glad to see you guys again. Thank you for joining.
Cool. Very good.
Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.
Bye.
Thanks.
And stop recording.